Hi there guys, welcome to this video on the binomial expansion. Now, let's just start with looking at these problems here I've written down. So expand x plus y to the power of 0. Well, anything to the power of 0, that's 1. That's pretty easy. X plus y to the power of 1, well, anything to the power of 1 stays the same, so we have x plus y. X plus y squared, okay, I can do that. So that's going to be first terms, x squared, outers and inners. I'm pretty good at those, so I can do both at the same time. So it'd be xy plus yx, or 2xy's, plus y squared. And it's at this point now, I'm like, oh crikey, this is going to take a little while. I'm going to have to write them out, expand the first two, and then, oh, no, the power of 7, I could do it, but it's going to take a long time. So as mathematicians, we were like, there's got to be a better way. And there is, thankfully. And we're going to look at two ways in this video. There's a lot to get through today, so please stick with me. But basically, binomial expansion, binomial, that's just an expression with two parts, two terms. So, for example, 2x plus 5, that's a binomial. If I put it in a bracket and I put a power, I'm expanding the brackets of a binomial. Okay. Now, this guy here, so in different countries, different parts of the world, they call him different things. But in Europe, we refer to what we're going to look at today as Pascal's triangle. I'm not sure why. He did it about 2,000 years later than everyone else that discovered it. But for some reason, in Europe, we take this guy. He did lots of good things with it though, so he is awesome. So what he said is, if you take row 1 and put a 1, row 2, you go either side. Now actually, some people call this row 0 and row 1. It doesn't really matter what you call it. So I just go for this. I don't like having a row 0. Now row 3, well, now it's going to get a bit more interesting. So we're going to put the 1s down, but when we get to these two, we're going to add them and put a 2 in, and then put the 1. So the 1s are always going to go down the outside. Row 4, so 1 on the outside, add these, 3, add these, 3, 1 on the outside. Now row 5, 1, add these, 4, add 6, add 4, add 1. Okay. So Pascal's triangle, there's some YouTube videos here about the mathematical secrets. There's loads of things in there. But this was really useful when we're expanding binomials, and you'll see why in just a second. So why is this useful? Now if we go to expand this, so I've just changed it from x and y, but that's a plus b. This one is a squared plus 2ab plus b squared. This one will actually be a cubed plus 3a squared b plus 3ab squared plus b cubed. Now I've clearly cheated a little bit there. I haven't expanded that in my head, and I didn't have it written down. I just know a little trick. But if I put these 1s in that we were speaking about before, let's just change the colour of that one. 1, 1, 1, 1, 1, 1, 1. You may be able to see the pattern between the others. 2, 3, 3, 4, 6, 4. So 2, 3, 3, and obviously the next one would be 4, 6, 4. Okay, so Pascal's triangle identified the coefficients of all of the terms in the expansion, and that's how I did it very, very quickly then. I've color coded it here as well, so you should be able to see a few more patterns. So it'd be great if you could pause the video and try and spot as many patterns as you can see. Okay, so if we focus on the blue, you can see it starts off with the whatever this power is here, a squared, and then it drops down a power, and then here in the last term it does become a to the power of 0, 1. So a cubed, a squared, a 0. A4, A3, A squared, A0. So that's a really cool pattern. But look at the greens. It does the same pattern backwards. Okay, and that's how I did the last one. I just started at A cubed, and then I went A squared, then A. I just took a number off. It was literally taking away 1. And another thing to know, and I'm just going to put some numbers here on red. Let's put 1s everywhere. That there isn't a 1. You should notice now the numbers added together always make this power, and that's always really, really important to understand. Okay, Now I've written down here row 1, 2, 3, 4, 5. Row 5 actually has 1, 2, 3, 4, 5 terms in it. That's another reason I like to call it row 5 rather than 0, 1, 2, 3, 4, because there's 5 terms in row 5. I just think that's useful. And the row is always one more than the power. So you could argue there's a negative there because that would be row 4 in the other way, but there's pros and cons, and it doesn't really matter, I promise you. So the 5th row would be to the power of 4. The 8th row would be to the power of 7. To the power of 12, well, that would be the 13th row. Okay? That, again, really not important, so don't even pay attention to that. Right, so let's just expand this now. Let's go for it using Pascal's triangle. So it's the power of 4, so we need row 5, so that doesn't take long. And now I'm writing like a awful handwriting, but there we have it. Okay? We need row 5, and that's got 5 terms. 1, 2, 3, 4, 5. Bosh, we're there. So what I'm going to actually do, I don't like writing this horizontally anymore. I'm going to write it vertically. So it's going to be 1, 4, 6, 4, 1. If I write it horizontally, when these get bigger, you just run out of space. Now you'll notice, let's just go back here. It starts off with this term to that power. Okay? So in this one, that term was a 2. So let's go 2 to this power. 2 to the 4, 2 to the 3, 2 squared, 2 to the 1, 2 to the 0. Then it went to this second term, but started from the other end. Okay, so let's go to this second term. I'm just going to change the colour again. So 3x, 0, 3x, 1, 3x. So I should be putting brackets around these. Just going to pop those in now. Squared, cubed, and 3x to the power of 4. Remember what I said about the numbers? They have to add up to make this power. Really important. You know, if you had 4, 3, 2, 1 here as well, then you should be able to see clearly that it would be wrong. Okay, so now you just have to work these out. So 1 times 16 times 1, well, that's 16. Now I'm going to write this one a little bit slower. So 4 times 8, well, that's 32 times 3 to the x. Sorry, 3x. This is going to be 24 times, be careful here, 9x squared. 4 times 2, 4 times 2 is 8, and that's going to be times 27x cubed. 1 times 1 is 1, and this is going to be 81x to the power of 4. So it's still quite a bit of work, but it's definitely easier than doing 4 brackets, right, next to each other. That would be awful. So what do we have? We have 16 plus 96x. 24 times 9, I think it would be quicker if I type that in. 216 x squared. 27 times 8 is again 216 plus 81x to the power of 4. So you can see the power is ascending. So smallest to largest, that's the first 5 terms. Well, no, that's all of the terms, sorry, of that expansion. Right, but wow, Pascal's triangle. What about if I had row 12? That would take ages. There must be a better way. So yeah, we worked it out. We worked out how to find those numbers, and it's called this wonderful button. If you've done any perms and coms, we've seen this about the combinations. Have n combinations of r, or have n choose r. So on your calculator, above your divide button. So if we go back to this one, to the power of 4, we know that's row 5, and that goes 1, 4, 6, 4, 1. So on your calculator, if you have 4, choose 0. So what you do, you press a 4, then you shift divide to get the NCR button. A little C appears, just like you can see. You press 0. It's not subscript and superscript like you write it, but that gives you 1. and as you go down here, you get the numbers in Pascal's triangle. Now we're not going to talk too much about this now, but this sometimes written in books like that. I don't know why, maybe it's easier, quicker when they're making the books. But it's calculated using this, and this is something you do need to memorize. Today, we're not going to worry about it too much. We're going to come back to this in future videos. But you do need to memorize that. And this factorial symbol, I will also talk about that in the future videos. But hopefully, you may know something about it already. So today we're just going to go ahead and use it, and then we're going to come back and understand how it works. Okay, so 2 questions to go. Let's find the first 4 terms. So there's going to be more terms because there'll be 7 for this one. So what we're going to do is we're going to find the first 4. So that's, sorry, have 6, choose 0, have 6, choose 1, have 6, choose 2, have 6, choose 3. 4 terms. If I continue that, I'll get them all, but we don't often ask you to go past 4 terms because we want to ask you more fun questions. So that first term, we're going to write every single time. So 2x, 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 and 2x. Remember at the start, you could see it going from left to right, the same term dropping down a power. So let's drop it down a power. 6, 5, 4, 3. Then we move on to the next term. So we've got 3, 3, 3, and 3. This time, remember the powers have to add up to make this one, and they go in reverse order. So 0, 1, 2, 3. Let's work out what these are. So have 6, choose 0 is 1. 2 to the power of 6, that's 64. So we've got 64. Why do I put times? I never do that. I like brackets better. So you have 64 x to the power of 6. 3 to the power of 0 is 1, so I'm not going to bother writing it. Have 6 choose 1 is 6. We have 32 x to the power of 5. And then we have another 3. Now I don't know that one, so off by heart. So have 6, it's probably 10 or something. 15? Yeah, 15. Now, you can just obviously divide by 2 as we're going down a power, so that's 16 x to the power of 4, and we times that by 9. This one's 21, but I wouldn't want to say, oh, it's 20, see, I was wrong. Good job I typed it in. And we have 8x cubed, this time times 27. So what do we have? The first 4 terms are 64x to the power of 6 plus 18 times 32, 576 x to the power of 5, 15 times 9 times 16, no idea why I typed it in that way, I get 2160 x to the power of 4, 20 times 8 times 27, and then we end up with 4320 x cubed. I'm going to put plus dot 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 just to acknowledge it is going past the first 4 terms. But there you have it. Isn't that great? Much quicker, super easy as well. You know, just writing in columns, nothing hard. Okay, the minus could catch you out. First 4 terms again. So this time power of 5. So it's row 6, but we're not going to ever bother about that ever again until we do the NCR bit. So when we work it out with the factorials. So we have 5, always matches, that's how many we have, and we're choosing 0, 1, 2, 3. That's the first 4 terms, 1, 2, 3, 4. So the first term of the binomial, so write it every single time, and count the powers down, 5, 4, 3, 2. Move over to the second term. It's minus 2x. Take the sign. We took the sign before, but because it was positive, it just didn't really look like it. And reverse the powers. Remember, they must add up to make 5. Well, whatever that is, it's not always 5, obviously. Have 5 choose 0, that's 1. 3 to the power of 5 is 243, and that's 1. That's 5. 3 to the power of 4 is 81. Now we've got minus 2x to the power of 1. Well, that's odd, so that stays as a minus. Okay, what does have 5 choose 2? Going for 10. Yeah, that's 10. 27. Now, minus 2x times minus 2x is 4x squared. Anytime you have an even power, it's positive. Please remember that. So have 5 choose 3 is 10 again. So we've reached that symmetrical point. So the next one will be 5 and then 1. Oops. So we have 9 and it's odd, so it's going to be a minus. So 2 cubed is 8. Right, so we have 243. 5 times 2 is 10, so we have minus 810x. What's that, 1080? I hope so, because I've written it. And minus 720x cubed. So there's the first 4 terms. Okay, hopefully you followed that, you really like it. Really fast way of expanding. You would not want to put 5 brackets next to each other. So this is super. Best of luck!